Hello students, today we will discuss about basic electronics. So what is this basic electronics all about? Yes, it deals with electrical circuits that involve active electrical components and associated passive interconnection technologies. So that means we are looking on to what are the different components in a electrical circuit. So there are two kinds of components, that is active and passive components. So active components, you can see transistors, silicon control rectifiers, MOSFET as active, and while the passive components include capacitors, inductors and resistors. So what do you feel as the difference between active and passive components? Any guess on that? Yes, have you heard of transistors? So transistors are those which can amplify a voltage or a current given to the system. So it is like a source of power over there. While in the case of passive component, they are just passive, which means they do not produce any power as such. They will be just storing or discharging, as can be seen in capacitors or as inductors, and then resistors, which resist the flow of current, or correspondingly a voltage drop can be increased. So all those do not contribute to any new power or any generation of power to the circuit. So we can, in that way, in that sense, you can define the active components as those which can act as sources of energy. So they have amplifying components like transistors or triode vacuum tubes and tunnel diodes and so on. While passive components includes, they are not a source of power. So they may be changing the voltage and current, but they won't be generating a power as such, so there is no power gain. So the components are resistors, capacitors, inductors and transformers, which can control the amount of voltage or amount of current that is passing through it, that's all. So in this session, we'll be discussing on diodes and transistors, which are the basic components, active components in an IC chip, or which is there as the basic component of your integrated circuits you use in your processors, smart devices and all. They all consist of both active as well as passive components, but we are going to discuss on what are diodes and transistors, which can act as active components. So before going into the components as such, we must see what are the materials we can make as a diode or a transistor. So coming on to solids, we know solids are those which have atoms which are closely packed. So we can divide the solids into non-crystalline materials and crystalline materials. So the crystalline materials are those in which the atoms are arranged in a regular or orderly fashion in all the dimensions. So it is again divided into conductors, semiconductors and insulators based on their conductivity or based on their energy band. So we must know what is the speciality of energy band in those three type of crystalline material. So for that, let us consider an atom alone, that is an isolated atom. So here you can see there is a nucleus at the center and electrons are revolving around the shells, and we have seen the energy of these electron can be represented using a horizontal line. So that corresponds to the lowest energy, that is 1s, then higher orbital energy, that is 2s, then still higher energy 2p and so on. So here we can see the energy levels are actually discrete, that means single lines ആയിട്ടാണ് another depicted. This is for a single atom, which means there are no nearby atoms to affect the energy levels of this atom. Now let us suppose that there is one more atom present in nearby the atom. So now you have two atoms. So what you can see is that the energy level of the first shell will be for the first atom and the second atom. And can they be the equal? No. The electrons from the Pauli's exclusion principle, we have seen that they must have a slight difference as required by the Pauli's exclusion principle. That means no the states can be the same for electrons. Okay, so if you add one more atom, what will happen? You can see that there is a closer energy level to the first orbital and similar to the second orbital and to the 2p orbital. And if you go on adding more number of atoms, for example, if there are 10 atoms, you can see 10 closely packed lying energy levels. So you know that there are not the 10 atoms present in a solid state. There are millions of atoms present. So when you consider all those together, what you get will be a band structure. So we can see if you add any number of atoms, the energy levels, there are certain energy levels which are not occupied by any of the electrons. So those are called band gaps. So there are gaps between the adjacent energy bands. So we will be describing or distinguishing the conductors, semiconductors and insulators on the basis of how much is the band gap between conductors, semiconductors and insulator. So here you can see that in conductors, what is the speciality? There is no band gap at all. The conduction band and valence band are overlapping with each other. So what is this valence band? It is the topmost filled or the outermost filled level of energy level of the atom. So that is what you mean by valence band. And in the case of conduction band, those are the energy levels occupied by free electrons in the atom. So and hence I need conduction, because the free electrons are the charge carriers which facilitate conduction, and hence the energy possessed by free electron is called conduction band energy. Okay, so in conductors, what is the speciality? Here you can see that there is no gap between the conduction and the valence band. They are just overlapping with each other. So what happens? There are more number of electrons readily available for conduction. So that is depicted here. You can see there is overlapping conduction band and valence band. There are plenty of free electrons facilitating conduction, electrical conduction, and hence they will have high conductivity among these three type of crystalline materials, and hence they are named conductors. And coming to the second category, that is semiconductor, can see there is a narrow band gap of the order of 1 electron volt between the conduction band and valence band. So valence band are the outermost filled levels of or energy shells of the atom present in the solid. So they will constitute a band called valence band. So there are electrons which are bound to the atom or the nucleus. So when you give sufficient energy, but they are not that much tightly bound to the nucleus. So when you give a sufficient energy, an electron can gain energy and overcome the narrow band gap and become conducting, become free, and hence those electrons will be occupied in the conduction band, which means those are the energy corresponding to the free electron. So what will be the number of free electrons compared to the conductors? Yes, you can see we have to give energy in the form of temperature. So when you increase the temperature, more number of electrons can be freed and can have energies in the conduction band. So they are few in number. They will depend upon the temperature at which the material is set. Okay, so when we we remove an electron, what will happen? There is a vacancy of electron in the bonds of the atom. So that vacancy of electron in the bond between atoms in a solid is called hole. So the number of electrons freed will be equal to the number of holes that is formed. Okay, so in semiconductors there are two kind of charge carriers facilitating conduction. In conduction band there will be free electrons for conduction, while in valence band there will be holes facilitating conduction. Okay, so in semiconductors there is a narrow band gap, so it is easier to free electrons from the valence band and make it to the conduction band. So we can say there will be very few number of electrons present in the conduction band at a given temperature, that is at room temperature itself. So we can mention it as partially filled conduction band, while the valence band will also be partially filled, in the sense some of the electrons has been removed and made free, so they will be partially filled. So we can increase the conductivity, that is the flow of free electrons and the holes in conduction band and valence band respectively, by increasing the temperature, or you can add more number of atoms, impurity atoms, which we call it as doping, and increase the conductivity. That means in semiconductor there is a possibility of controlling the conductivity of the charge carriers. So if only if there is sufficient energy, electrons will be able to become free or conduction electrons. So what will happen at 0 degrees Celsius? 0 degrees Celsius, there is no energy provided by the temperature. You know what is the temperature, thermal energy that is obtained due to temperature. What is it? It is given by, thermal energy is given by kBT, isn't it? So if there is no temperature, T is equal to 0, then what would be the thermal energy? It will be 0. So there are no energy provided to the electron in the bonds to make it free. So will there be any conduction electrons? No. So it will act as the second type, the next type of material, that is insulators. So insulators are wide band gap material, or we can say they will have electrons very tightly bound to the nucleus. So it is very difficult to remove those electrons. Even if we give sufficient energy, we are not able to remove that electrons and make it conducting. So here it is the order of 15 electron volt. The band gap is order of 15. So very huge amount of energy has to be supplied to make it conducting electrons. So in general we can say they will have full valence band, which means the electrons are occupied in the valence band, while there is no free electrons in the conduction band, so it is an empty conduction band. So semiconductors at 0 degrees Celsius behave as insulators. Why? Because there are no free electrons in the conduction band, so it will not have any kind of conduction. Okay, that happens only when it is 0 degrees Celsius. Now, for insulators at room temperature or any other temperature, they will have no electrons in the conduction band, and all the electrons will be bound in the nucleus, bound to the nucleus itself. So no free electrons and holes, so they do not conduct electricity, and they have, or they can, and hence the name insulator. While semiconductors, the conductivity will be lying between that of conductors and insulators, and hence the name semiconductors. So that ends the topic for today. Thank you.